We're going to be talking about solving exponential equations. So let's take a look at a problem we're going to have. 10 to the x equals 25. Solve for x. Okay, now the problem we have here is that my x is in the exponent. I've got to get it out. So to do this, we have to work with an inverse function, which is our log. So let's go in and take a look at the steps we're going to use. Step one is to isolate the exponential on the left, which is the way they gave it to us. All we want on the left side is just the exponential term. Everything else we want to put on the right side. Step number two then is take the logarithm. Step number three if not base 10 or base e, use your change of base. Formula, which we talked about in the last video. And you want to use, remember it's a natural log of your variable divided by the natural log of your base. And you want to use ln if at all possible. Okay, so once we've got this, then step four is solve. All right, so let's take a look at the equation we got, or an example. So we start out with 10 to the x equals 25. Okay, step one, isolate exponent on the left. Done. Step two, take logarithm. How do you know which logarithm to do? You use the same base as you've got here. So I'm going to take log base 10 of 10 to the x will equal log of 25. And log and 10 to the x are inverse operators. So they go away and I'm left with just what I have up here. So I'm left with x equals log of 25. All right, I'm in base 10. So at this point now, I plug this in the calculator, and it's approximately equal to 1.398. Okay, let's take a look at another example. I've got 3e to the x equals 10. Okay, now, I'm not quite isolated. There's my exponent. I've still got this thing. I've got the 3 out front. So I divide by 3. So I end up with e to the x equals 10 thirds. Okay, so now I can solve it. So I take logarithm, and because this is base e, I'm going to use natural log of e to the x equals natural log of 10 minus natural log of 3. If you don't see how I got that, go back and review your log laws. Log of 10 over 3 is the same as this. And those are inverse. So I'm left with x is going to equal to log of 10 minus natural log of 3. And I put that in the calculator, and it's about 1.204. Okay, so one more, actually more than one example. Let's work another one here. 4 plus 3 to the 5x power equals 8. All right, well, there's a lot going on here, but again, the old classic thing, take these things one step at a time. So isolate the exponential on the left. That's my first step. Well, first thing I need to do then is move that 4 over, which is by subtracting 4. So I'm going to be left with 3 to the 5x equals 4. All right. We're left here because there's my base and there's my exponent. So at this point we can take the log, and because my base is 3, I want to do log base 3 of 3 to the 5x equals log base 3 of 4. And you have to do it to both sides. Inverse operator. So I'm left with 5x equals log base 3 of 4. And now I divide. So I'm going to be left with x equals log base 3 of 4. And log has the same order of operations as exponents. So it's very high. So you have to do that first, and then you divide whatever the log base 3 of 4 is by 5. All right. So we've come down, we've gotten that point. I've got the logarithms. And I am not in base 10 or natural log, so I've got to use my change of base. So I'm going to be left with x is going to equal to ln of my argument over ln of my base, which is 3. 5, I multiply by 5 in my denominator. Okay, when your instructions tell you to leave it in exact form and not a decimal approximation, this is the form they're asking for. They're asking for to leave it in ln form. Do not leave it in log base 3, convert it to the natural log form in order to solve it. All right. Another thing then let's look at, and this looks really nasty, but it's not. Okay, now believe it or not, this is a quadratic. I'm going to show you why. I'm going to do, first off, when we take a look at this, e to the 2x is the same as e to the x squared minus 3 e to the x plus 2 equals 0. Okay, now you may still have a little bit of trouble, so let's do a change of variable where I'm going to change e to the x for a. So I'm going to come back in and let a equal e to the x. So now I'm left with a squared minus 3a. You see I'm just putting an a in, and everywhere I've got an e to the x, plus 2 equals 0. Okay, now this thing you should be able to recognize as a quadratic. All right, and so what we do now then is we're going to factor this. So it's going to be a minus 2, a minus 1 equals 0. And when I solve this, I end up with a equals 2, a equals 1. All right, well, you don't see this, but remember we substituted it in. So now I'm going to put my e to the x back in, so I'm left with e to the x equals 2, and e to the x equals 1. And to solve these, you notice I've got my exponentials on the right here. So I'm going to take the natural log of e to the x equals natural log of 2, and the natural log of e to the x equals natural log of 1, or x equal natural log of 2, or x equals natural log of 1. And the log of 1 is always 0, so that one is x equals 0. And there are your exact solutions. Okay, now on your homework problem, I'm going to give you a big hint on it, and I do mean a big hint. You're going to be working one very similar to this, except you're going to see an e to the negative x, which is the same as 1 over e to the x. These are these rational exponents. They're back. Now, in order to make this look like what I had up there, multiply all, not just the ones you like to, but all terms by e to the x. And if you do that, you should get an equation that looks like the quadratic that I had above. All right, I want to work one more example for you. 5 to the x minus 2 equals 7. Okay, we're back off to this one. This isn't one of these little funky quadratics. So I isolate my exponent on the left, done. Take logarithm, so it's going to be log base 5 of 5 to the x minus 2 equals log base 5 of 7, or x minus 2 equals log base 5 of 7, or x equals log base 5 of 7 plus 2. All right, I still don't have that, so I need to change this. So x will be equal to natural log of 7 over natural log of 5 plus 2. And that is the answer to this one. This is the exact answer. Leave it as it is. Leave these as a natural log. Okay. You're going to be getting some questions I'm going to put from Amarillo College on here. And if you do the decimal approximation, I will give you 0 credit for it. I'm going to be expecting to see all of this work right down here to get to the answer.